Okay, so pretty short week. I imagine that's true for everybody. It's May 8th. Glad to see everybody again. We had last week off because we were all busy with life, and I expect probably everybody's lives are still pretty busy. So, um, but it's good to get back together, even if even if we all didn't do necessarily a ton of stuff over the last 2 weeks. I don't know. We'll see what turns up. Hudson did a lot of stuff, so he can pick up the slack for all of us. I wrote a whole presentation. All right, so let's see. One of the things, this is actually just sharing stuff that was in the news. One of the things that we've been kind of interested in the last couple of years in the lab is measurement of trees. Our approach tends to be a little bit different, so we're often kind of more interested in urban trees as opposed to sort of natural forest, which is more kind of a freck thing. Um, but so building like really high detailed models, height for a long time has been pretty easy to get. Diameter a little bit less so. I just got an email about Earl's paper just a couple of days ago and just replied right before the meeting. Somebody had read the paper and was interested in kind of using it, which was really exciting. I wanted to hear a little bit more about it. But one of the things that we have on campus that's really nice is a really fairly extensive tree database, but for a while it was kind of hard to come by. Like it existed, people kind of had it, but people weren't sharing the links or whatever. Anyway, there was a really good article in the VT News about it where they were talking to the arborist, and I want to send him an email. But in the article was a link to an ArcGIS layer where you can at least load it and look at it, which means it's accessible. So I kind of wanted to just kind of get this in the lab archives of here's a URL or here's a place to find it, kind of moving forward. We don't have anybody working on this at the moment, but maybe we will at some point again. In a lot of my spare time, I've been thinking a lot about the autonomous rover that I'd like to build. As we're kind of getting the RTK GPS stuff dialed in, I think it's getting more and more feasible to use a rover to do a lot of the work that we would like to do. It solves a lot of problems with airspace and congestion and safety. It won't work everywhere, but I think in some environments this could work really well. And we're already building our own custom quadcopters, so we may as well build our own custom rover. It's not that much extra work. It's the exact same technology, same controller, same everything. The big thing that's different is that the motors are different. So because the pressure on the motors is kind of against the axle rather than sort of top down, we need sort of entirely different motors to make this work, but everything else is the same. So I've been kind of looking into what that takes. I don't really have any experience with like RC cars. I had one when I was like 10, but it was not good. And I don't really know how these things work. There's a ton of YouTube videos where they're sort of talking about reverse engineering a number of technologies, including sort of just standard off-the-shelf RC cars, power wheels, hoverboards. What else? I guess that's most of it. But I want to kind of start off small, and I don't know whether it's easier to just buy the motors or to buy something and then reverse engineer it. So I've been kind of going back and forth about a ton of that stuff. The kits are really expensive. So like this is if you go to like Robot Shop, the Lynx Motion kit is like $300. That includes the motors, but still that seems really pricey for what you're getting there. All I really need are motors. In fact, this kit, that's the Racer Star, includes an ESC, which I guess we're going to need some beefier ESCs. That sort of makes sense. It's going to be heavier, I suppose. So I just need to do a lot more research. I know a lot about building quadcopters, but I don't know anything about building remote radio control cars. So it's just kind of a bit of a learning curve there. One big question is whether we want to do skid or normal steering. It seems like most of the robots use skid steering, which means the wheels don't sort of change orientation. You just sort of activate wheels and move them forward and move them back, and you kind of turn the thing that way. I guess there must be a reason why people do that. It seems like it's fewer parts to break. I don't know. Thoughts on that?
Yeah, I would think it'd be a lot simpler because you wouldn't have to have like a um, steering rack or anything, and you have 4 individual motors anyways, so you don't have to worry about like a differential.
Yeah.
You just wear through tires faster, but that probably isn't cheap or
Yeah.
isn't inexpensive.
You do
Yeah.
tracks.
Yeah, tracks would be interesting. I've seen a lot of stuff on that. It seems like most people just do like a 2-motor solution, and then the other 2 are just sort of trailing wheels um, to kind of simplify things. Like you don't necessarily need 4-wheel drive for a lot of stuff. So I guess I'll probably start there, just sort of a 2-wheel drive skid steering robot, and we'll see how it goes. But I want to get the Busy Bee flying. That was like 95% done when I left it off last year. So I guess I might as well get that flying first. This was a cool thing that I kind of found. This is an off-the-shelf rover system. It actually integrates with ROS, kind of off the shelf. So if we wanted to just buy something, I think this is probably what we would buy. But they didn't list the prices on the website, which means they're probably pretty expensive, at least a couple $1,000s. So whether we want to spend that or not, I don't know, maybe. And then the other big thing was Hannah Ebo, who's a student at NIU. She finished her thesis last year and is kind of getting it out for publication. So she's submitting her revisions for that. So me and the rest of the other co-authors on this responded to a number of the kind of remaining sections, but I think the idea is that this is going to get submitted back, the revisions, within the next week or 2. So always exciting to get a paper out the door. It only happens a couple times a year. So goals in the next week / 2 weeks. One is I know that I've got proposals to read. So Jim and Sam and Colleen, I need to take a look at your stuff. Jack, I went through your stuff a couple of days ago and we talked about that. But hopefully I'll get through some of that stuff today. I've got some theses to read. It's thesis season. So Riley and Molly, both kind of friends of the lab. I'm on committees for them. So I'll be reading their theses within the next week or so. I'm still pretty interested in the pictometry oblique photo exploration. I didn't really talk about this, but this was, I think you guys have probably seen this in the lab. This is a 3D print of the NIU campus from photogrammetry data, which I like a lot better than the stuff that sort of comes out of like DEMs or DTMs or DSMs, because you get a lot of texture and you can see like the trees have actually some structure there instead of just being like vertical blobs. Anyway, I rigged up a system and this worked really well. I can like scan this QR code and then you kind of put it under this camera and shine the laser pointer on it. I actually tested that out. I got it out of mothballs and everything was still working fine, which is always nice when you write code and you put it away. You never really know if it's going to work again when you get it out 2 years later. So, but it did work. And if I can get the pictometry oblique photo stuff, I think we have a pretty good chance of developing a reasonably good model for campus. There's, you know, since flying seems to be kind of out the window, I think that's our next best option. Another interesting option, by the way, is you can actually construct 3D models from fly-throughs on something like Google Earth. So we could potentially use Google Earth Studio to create a fly-through and then use that to feed a Pix4D reconstruction based on the model. People have done that. I think it works okay. I've never done it myself, but that might be kind of a fun thing to try. Basically just recreating the Google Earth model for ourselves. I got a lot of the imagery for the Roanoke Impervious Surface project. So they wanted an automatic classifier for impervious surfaces. I'm kind of looking forward to seeing the work that you guys are doing in machine learning, because I think a lot of those techniques can be applied to this problem, sort of off the shelf stuff. But I did get all of the imageries, like 80 gigabytes of 6-inch imagery over the last few years from Roanoke. So that's kind of a neat find. And that's all on Maverick, which I need to make a copy of. I need to finish the RU paper, so that's the deadline for that, I think, is May 30th. So we're really getting to the end of my rope on that one. So I really, really, really have to finish that off. And then I wanted to talk about when we're going to meet, which is now that we're kind of beginning summer mode. We typically don't meet every week. Everybody's going to have other things going on. It's nice to, we found that it's nice to kind of keep a little bit of contact. It keeps everybody kind of moving through research a little bit over the summer. It's nice to see faces. It lets everybody kind of get a little work done over the summer rather than just sort of forgetting about it. So I guess my proposal would be to try to meet every 2 weeks in the summer. It wouldn't be required, but if you can make it, not a bad way to kind of get back together. Does that sound reasonable to everybody?
Sounds good to me.
Yeah, I agree.
Okay, cool. So that'll make our next meeting the 22nd of May. And that's it for me.
Good.
Oh, I lost my screen share. All right. Okay, screen sharing should be enabled for everybody now.
I mean, I can go if Hudson doesn't need to go.
No, I mean, I don't have slides other than my defense slides. So, I mean, it'd be cool if somebody, if you guys have a chance to put your eyes on that at some point. I think Dr. Pingle dropped the link. It looks like a Zoom link, but it's actually a link to the recording itself.
Oh, okay. I'll definitely watch that for you.
Appreciate that.
Cool.
But
Yeah, I just sent you comments, Hudson. You got those?
Is it directly in the Google Slides?
Actually, I sent it to you via email.
Okay.
So check there. Yeah, I watched it this morning. It was good. The length is good, 25 minutes or so. So not terrifically long. I just took some notes kind of as I was watching. But yeah, nothing substantive. I mean, nothing that would require a lot of revision or anything like that. A couple of suggestions here and there. But yeah, it was good. Anybody else have time to watch it already?
Yeah, as I was like,
the link yesterday, so.
Yeah, as I was like talking through it, there was like definitely slides that I wanted to go back and revisit to brush up and make sure I hit some key points. But yeah, appreciate you taking a look at that. So.
Sure.
All right. I guess I'll go ahead and go then.
Okay.
So here's the lab report for this week. You know, baby and machine learning project. So Darcy Ann Young, born 429, 7 pounds 6 ounces and 20.75 inches long. This is a picture during her first bath. She's smiling.
Wow.
She's cute. And then machine learning project. Been working with Sam and Jack on this. ArcGIS deep learning is really finicky. It's really frustrating. And based on some small like Googling, the suggested composite for burned area mapping is with Landsat 8753 bands. So RGB, 753, because it actually really highlights the burned areas as a dark orange red. It's pretty interesting. And then anticipated goals. It didn't get a lot done this week or last week because of aforementioned baby. So yeah, I did work on the machine learning project that's due Monday. But next week I plan on getting the proposal finishing edited, hopefully. I'll probably work on that some more tomorrow, get all my homework done for the semester. So I got 2 more assignments left, including the machine learning project. So hopefully going to get that done. Do curvature comparison and try and read my articles again by the end of next week, since after Monday I don't really have anything to do. So yeah.
Can you send me that GIF?
Oh, of course.
Thanks.
Can you CC me on that too? I can go after Jim.
All right.
It's in chat, by the way.
Thanks.
All right. Can everyone hear me? All right, cool. Share. There we go. So it's the final countdown. We're almost done. This week has been machine learning and machine learning. So I've been like putting a ton of hours into it. But I think it's been some pretty good progress because this might connect into my thesis. So just kind of like a background, like what Jim said, we've been working on, so for our final project, just building kind of just a model to detect burn scars. And this is the Campfire from California 2018, just in false color infrared, and then GMB.
Where was the Campfire again?
Paradise, California. It's
It's in Northern California somewhere, I think.
So the one kind of by.
Yeah, right up here.
Okay.
Oh, there we go. So, yeah, the fire kind of started over in this, like this area over here, and then spread over to Paradise and like engulfed the town. It's pretty big. I think one of the most expensive fires, but it seemed like a good case because it's just kind of like very localized. Because some fires, they just kind of hop and skip, and it's just a series of these fires. But this is like a huge, like localized, not localized, but kind of clumped together fire. So we've been using ArcGIS Deep Learn to do it, and it works beautifully when it works. Like I'm tired of staring at the little red flag that pops up. Oh, there's been an error. And I documented some of the solutions in here too for reference, because there's a lot of problems. And the thing that was kind of frustrating was it was like it wasn't telling you what was wrong. You had to like dig deep for them. But I'll start with kind of our methods. I found this really cool open source project called diagrams.net, and you can build these really cool diagrams for free, and the software works great.
Awesome.
Yeah, so I was trying to export as a PNG. It looks a little bit nicer, but it was like Google Sheets or Google Slides was giving me some problems, so this is just a screenshot. But so we have, this is kind of like for our paper, so it's a little bit like watered down, I guess, but we have our Landsat imagery, the campfire. We break it up into our false color fire imagery, our 752, and you get this kind of cool, like maroon, reddish, where the burn marks are, and then green, bright green where it's healthy, and then like this really deep blue for water, which helps contrast it nicely. So one of the things was the packages that, so ARC ties into like these, like PyTorch and all those types of packages. And one of the image processing packages they use is Pill, and it only takes 3. It can only handle images with 3 channels in them. So like we were trying to give it like 8 bands just to see what would happen, and nothing was working. And it turned out that we needed to tell it what the 3 bands were. So that was I would say it's a pretty significant limitation. Like you can't just throw it whatever you want. You have to like, it's designed for like the cat versus dog problems.
Yeah.
So it's not really built for like what we're using imagery for. It's more like images, I guess.
Can you so let's say you wanted to throw, I don't know, 6 bands at it. Could you just construct 2 RGB fake images, like false color images, and give it that? So like on a lot of deep learning stuff, what they do is they'll do some interesting tricks, and they'll like mirror the image, or they'll rotate the image.
Yeah.
And they'll use that as part of the training.
Right. So it seemed like, so one of the things that I noticed we had problems with was if you're trying to like, it automatically wants to append your training data set, so you can keep creating training data. So like if you want to like start over, you'd have to delete that whole directory. But I think like we could add training data, so maybe like do multiple images would work. Yeah, that's a good idea, like over the same space.
What would worry me about that is when you apply it to the test data, it might be kind of confused about which bands are actually which.
Yeah.
So like if you're feeding it, say like the 752, and say like, I don't know, just some random ones like 741.
Yeah.
And then it won't be able to tell which bands it's looking at. It might look different, because when they rotate it, I think that's more so that they don't, so that they can perceive that image in any orientation. So it's not like, say, if you're trying to find a bird, it's not like you're always trying to find a bird that's like flying in the same direction. Does that make sense?
Yeah, that makes sense. Yeah, that's interesting. But it seems like they designed it that you can, if you have like Digital Globe or was it Maxar, right? They have like those satellites just persistently scanning an area. It seems like you could just collect all that imagery together and just dump it and have it train on all of it. So I don't know. But so you get this 3-channel raster stack. Jack also had a really good idea of calculating fire indices for each one of these. So 3 different fire indices and making those the 3 channels, which would be pretty interesting. But you get this 3-channel raster stack and you have to convert it. The big ones, you have to convert to an 8-bit unsigned or 16-bit. Because I think it was libtiff they used to like bring in the images to like Pillow, I think, or something internal, and it won't work if you're giving it just raw Landsat imagery. You have to convert it. And this is kind of like the pre-processing. You have to do all this, and then the rest of the model works pretty good once you have it all set up perfectly and exactly how it wants it. So we had our create training data. We used a chip raster function, which works really well. So you give it your imagery, you tell it how big the spaces you want, like how big the tiles you want, and then the overlap, and it breaks it up really quickly into your chips. And then what it does is it labels your chips based off of, there's like a couple different types of labeling and like classification tools like Kitty, classified tiles. I'm trying to think of, there's one called Pascal, which I think is for like detecting, like if you had cars on the road, detecting each one of those cars. But you give it your truth data, which we found this, Jim found this cool product from Landsat that it's like some fire detection algorithm. So I just downloaded that, but it was kind of messy. So we just trimmed it to where the Cal Fire drew their polygon, fed it to this. So it chips our 3-channel raster stack and then classifies it based on our truth data. It's these chips. Excuse me. And then we go straight to our train model. And we ran a UNet pixel classifier, mostly because it, like, depending on how you chipped your raster and like how it's classified, it gives you options to what models you ran. So this was just like the one it gave us, which was pixel classifier, which sounds about right. So it's going to determine if each pixel is a fire pixel. And at UNet, I was doing some research on it. I think it's a fully convolutional neural network. So you can break up into a couple different classes. I have to do more research on it, but it's a CNN type model. So you build the model and it runs on the GPU pretty well. There's some things that I was like hammering the CPU a lot for. And then once you get that model, which is nice, it has like this little directory file with like a DLPK and then a deep learning package. And then you grab that deep learning package and then you run it with your imagery you want to classify, and then you spit out raster. So it works pretty good, I would say, once you get it perfectly. Like the big key part is this pre-processing and getting it the way that it wants it. But yeah, I documented the problems that we had, or sorry, our initial output. So this is like version 1 of our model. We have our original right here, so you can see the burn mark. This is just RGB. We have our training data set, which is that Landsat burned raster. And then this is our output, which I thought it did pretty good. It's picking up a lot on the shores and like some random like fields that like are empty. But one of the interesting things was there's this blob over here. And we're like, oh, we're like, oh, the model's not performing that well. But we zoomed in and we looked at it, and I think we need to cross-verify this, but it looks like there's a fire over here.
Yeah.
So when we were just running our data to see how it looked, it picked up on a fire that we didn't even notice. So I think it's promising. I think version 2 and 3 are probably gonna be better, but this is just kind of like our initial run. So here's some problems and solutions. You have to get the Conda environment perfectly correct. There's documentation online and deep in the Esri kind of black hole of the Esri online stuff But you have to install like these packages in these exact versions, or it's not going to work and something's going to break, which is kind of frustrating because these are older versions. Like I think Keras is on like 2.6 or something in TensorFlow. So these are all older packages. But you can't do anything newer. Like you can't just do conda install PyTorch. It has to be this exact package. And don't upgrade it too. I've broken like 15 conda environments and I had to like reinstall it. So it's a little finicky. I wonder, my question for them would be, why are they like so dead set on using these really old like versions? Another one was, we were getting a lot of TIFF errors in the creating training data and then the training. So the one is, make sure there's not more than 3 bands of imagery. It's based off kind of like the old, or not old, but like a lot of these core packages are based off like the image classification, like cat versus dog. So they're built only for 3 channels. And then make sure it's 8-bit unsigned. I ran our data in 16-bit unsigned, and I remember the 8-bit from remote sensing is the maximum an eye can detect between colors. So 16-bit's kind of overkill. So we just kept it 8-bit because just to keep it computationally a little bit easier. Then there's this weird error. One of my frustrations is like a lot of errors that we're getting didn't have a label, like they weren't explaining why it was happening. So we kept getting this divided by 0 error. I need to investigate a little bit more about what's causing it, but when you're training and you get this divided by 0 error, I think it's related to your batch size. So if you have too big of a batch size or too big of a learning rate, it's going to cause this failure. I have to look more into it, but it's one of those 2 options that would cause that error. And then there's this really frustrating index error, list index out of range. So it appears to be a bug. I saw an issue made by Art, or by the Esri people. But I need to track it down. But when you're training your data, so what it's doing is it's looking for the image and it's looking for the labeled raster. So it chips all your images. So you have these blocks, and then you have another directory of labels, and it looks for the image and it looks for the corresponding label. But if your training data doesn't have a label for every single chip, so like you can't just classify, like in our case, we were just classifying fire and nothing else, it wouldn't, it would classify some chips as no fire, or there wouldn't be any fire, so it wouldn't classify as anything, so it wouldn't output a file, and that would cause it to fail. And they said it had to do something with the whatever option that like kitty labels was causing that problem, but we weren't using that. So I don't know, I think I have to look into it. But what we did to get around it was we made a new polygon called no fire and just put it around the areas that we didn't think there was fire, and it solved the problem. So it's kind of like when it's loading the data. Another problem was OS error -2. I have no idea what that means. It appeared in the libtiff module. This is during training. I think it's ultimately a problem with the training data. Too many channels are not 8-bit unsigned. The Esri forums, I've never had good luck with these. They're kind of a hit or miss. When I was looking for the index error out of range, some people kept saying contact tech support, and then another person said, why don't you search it? Okay, you know, that's why I'm here.
Oh, that's not helpful at all.
Yeah, and we were discussing it because I know we have a pretty serious contract with them. So I looked into seeing if we had tech support, and it doesn't seem like we have anything. So that was clearly not a viable option. So I don't know. I think the hard thing with this stuff was like just jumping into the code and seeing what was causing the problem. So the index error, I grabbed that chunk of code and I was just running it. And then I had to find the directory, and I found that the directory was missing this particular label. So it was kind of a mess. Yeah. Oh, yeah. So a lot of the errors can be connected back to training data. If the training data is not perfectly set up, it's not going to run on the model. So you need to research what your problem is and what kind of labeling schema you want to use. And then it's going to work nicely on the model, but it's not going to tell you if your training data is kind of bad. So you have to do a lot of a lot of like kind of research and pre-work to get your training data right, or what you think is right, and then see if the model works. So it's a little frustrating that it's not a little bit more intuitive, but it's kind of where it's at. Pros and cons. I think it's pretty favorable that I would use this in my thesis. It'd most likely be like a hybrid, so using deep learning to do some things, but outside sources to do others. I really like the raster chip function. It's super, super quick. The trained up model outputs in the, it takes the model and puts in a little directory with like a DLPK file, deep learning package, so you can send that to anyone and they can run it on their system, which is really nice. And then it also has like an HTML output that you can scroll through, and it pre-populates with graphs and like your loss function. And then it's extremely simple workflow. Once you get everything like prepared correctly, it's just 3 functions. But I mean, that's kind of an understatement because it's a lot of work to get it prepared correctly. The cons are the documentation kind of stinks, the error documentation. You can't use most recent packages, so you're not getting that cutting edge of what's going on in the deep learning world. The 3-band problem, and then they're really trying to like push this into like their proprietary own stuff because, you know, they want to make money like everything else. Geospatial, they want to like force everyone into a weird proprietary format. So the DLPK file is cool, but I'm kind of hesitant to use it because then your model's locked into this weird format that only they can use. And then,
Have you heard anything about other people trying to use multi-band images with deep learning? It seems like geospatial is a good use case, but maybe there are others. Like, I mean, I understand historically why it's been stuck in RGB.
yeah.
It seems like not that hard of an extension, right? Like, why?
Yeah. I don't know, and some RGB photos have like that 4th band, I forget what it's called, gamma or something, that people like to use. So I'd have to look into it.
We did a little Googling about it because Pillow's the one that doesn't like 3 bands.
Yeah.
But we found, because there's like remote sensing people wanted to use multispectral imagery, we found people were basically told them to rewrite Pillow for themselves.
Ah, helpful.
Yeah. I remember seeing an issue on GitHub for that. Yeah, and like the example, so like at Esri Federal and then like the deep learning seminar that got cut off too shortly, but it seems like this is really geared towards like Maxar kind of applications where it's just you got RGB imagery and they're just trying to identify pools. It seems like the Landsat and like Sentinel-2 space isn't what this is geared towards, but I mean, it seems to work pretty good based on our like initial results. So
yeah,
it's interesting.
It is a fair bit of overhead to say like which bands are going to be useful. I mean, you guys figured out which bands are likely to be the most useful based on previous research into fire, but I mean, it shouldn't be the kind of thing that you have to do. Like it would be, I mean, that's the whole fun of deep learning is you should be able to just sort of dump the raw imagery in and let it figure it out.
Yeah, exactly.
It's too bad.
Yeah, so it's interesting. I think it's been pretty productive, like working on this stuff. Then summer plans. So NGA was like kind of like dragging their feet and saying that they might cancel, and they canceled the new interns coming in. And then just this week or last week, they told us that they're going to run like a virtual internship. So I have no idea what that means. I think it just means I'm going to be sitting on my computer all summer long. I have no idea what I'll be doing. I think I'll definitely be with my research group in St. Louis. I've been talking with them a little bit, but it's going to be 10 weeks starting June 8th. So I still need to hear back about logistics, but I have a job, which is good. And then after this, so Monday, me and like Jim and Jack we're pretty much gonna be done with like a lot of our coursework. The like files gonna be turned in. So I think I'm gonna switch to like like a 9 to 5 type schedule, 40 hours a week working on thesis stuff. May 12th to June 7th, I'll be kind of doing that. And then I'll switch to NGA mode. I want to get my proposal out and then tinker with like version 1 of Tornado Model. And then think of good acronyms. That's my side project. Tornado damage detection, TOD. Sounds pretty good.
Yeah, gotta be pronounceable.
Yeah. And then, yeah, here's my goals for, I guess, this upcoming week. The big ones are Hudson's and Molly's defense. So I'll be in attendance. That's all I got.
Yeah.
Okay. I'll go next, I guess.
Where's my, how do I, my thing disappeared.
Press
Can't-
Alt maybe.
Yeah. How do I get out? Weren't you just having this problem, Dr. Pingle?
What's that?
Weren't you just having this problem? My thing.
Yeah,
won't
yeah,
come back.
it's a perennial problem. It's hiding there somewhere.
Oh, there we go. Jeez. Okay.
Okay, so the home stretch of this semester, thankfully, kind of surprised it's over. So some things I did. This is kind of like over the past 2 weeks because I already made my PowerPoint, so I just added stuff to it. HDL Graph Slam, I spent a couple hours doing that. Actually got it to work, which is nice. Ubuntu 20.04, I think it's called Focal Fossa. That spent some time messing around with that, and also ran some photogrammetry on a stick scans at 3 different heights to see how it did over the same area. And a lot of time spent on machine learning. Still need to finish up the proposal, didn't get to Google Cartographer. That's okay, that's kind of the back burner right now. So photogrammetry and stuff on a stick, I run it down on Smithfield Road. In Pix4D it says it's Plantation Road, but it's actually Smithfield Road. And I ran it here because the road kind of sucks. There's a lot of potholes that you can see, and I wanted to see if those would show up. Unfortunately, the worst part of it, I couldn't run it because there's actually some power lines that run across, which you can kind of see in this bottom right-hand picture against the clouds. But yeah, I want to stay from those. And so I'll show you in Cloud Compare what these look like. So this is the tallest one, and it turned out pretty well except for this weird stuff where it messed up the plane. But one thing compared to the other ones, which you'll see in a second, is that there's more of these gaps in the point cloud, and this is in the middle of the road, so it was pretty close to where I was walking. I was kind of walking along the edges of here. It didn't like some of the potholes with big puddles either, which I assume is just the water. It's like a difficult surface for it to pick up.
Yeah.
And I'm not 100% sure what caused this. I'm thinking maybe I got close to a tree and it confused it or something. I'm not 100% sure, but it didn't show up in all of them, which we can look at the half height one, which is a lot better. It's actually it's my personal favorite. You can see a lot of those gaps are filled in. It didn't like this big puddle over here. But some of the smaller things you can actually see, like these littler potholes, and it's like none of that weird stuff going on. You could even see this tree turned out pretty nicely, some signposts and stuff. One of these, this is a speed limit sign that you can almost read, which is kind of cool. And yeah, stuff like these fence posts, it's just right next to some pastures, turned out really well. And the short extension also had a little bit of funny business going on. I think when I was down here, a car drove past and that might have screwed it up because I had to kind of wait for it to go past. So I might try and just take out some images, especially if the images with the car are actually in there. But kind of as you might expect, the field of view isn't quite as good because this was taken with the camera is probably about like 5 feet above my head, so maybe like 10 feet total. And then the medium extension was at like 15, well, probably closer to 20 feet total, and full extension is like 35. But what it did get looks pretty good, except there is kind of like 2 layers to the road surface, so that's not super great. I'm not really sure what that's about. But yeah, oh yeah, here you can see the speed limit there. So yeah, the medium I think is best. There's not too much like flex in the pole. It's not too difficult to handle. And then the short just seems like you could do better.
It'd be nice to have a good way to do like a little bit of a guide to talk about fixing those multiplanar surfaces.
Yeah.
If you go through that and you kind of come up with a way that you think is a good recipe for people to repair that, that's likely to be something that's going to come up a lot. So,
Yeah.
your original photos, I'm looking in the directory here. It looks like you've got the Smithfield Road project directory.
Mm-hmm.
Did you archive? Google file streams being kind of slow. Did you archive the? Here they are. All the images are just kind of in the base directory. Got it.
Yeah, so I put the 3 different sets of images from the GoPro. There's in their own folders with like full, half, and short extension. Then there's one that's just photos with that I just took of the area.
Oh, got it. Okay. Cool.
So
it'd be interesting to run these through if you got them handy, just for your own playing around with this stuff. Can you try running these through Microsoft Ice and just see how it comes out?
For like orthophoto?
Yeah, I'm just curious to see what happens more than anything else. I doubt it's going to be very useful, but it also only takes a minute to run it. So
yeah, I can do that.
Yeah.
So HDL GraphSlam, I ran some test data from inside the halls of Wallace. It didn't turn out as well as the sample data, which is somewhere around here. There it is. It's kind of weird where it puts it in the like, oops. So you can see it's kind of that same thing with like multiple hallways going on like it. So yeah, it's not as nice and clean as the sample data from the people who wrote HDL GraphSlam. You can see kind of inside rooms, which is cool, but yeah, leaves something to be desired.
So what are the next steps to try to get that working a little bit better? So that's the exact same result that I had gotten. What do we do next to try to tinker with the algorithm? Because there are a lot of settings to try to get it to resolve better.
For me, probably kind of, I don't know, read the documentation because I haven't really read anything except for how to install it and run it. I haven't really had time to like really tinker with it that much, so it's, it can kind of work, and I know what people like to do is they kind of augment it with their own algorithms and stuff to help resolve these issues. And they do that with Google Cartographer too. So that's kind of, mixing in their own homebrew stuff to fix some of these issues. But yeah, I assume that will probably take some more work that I just don't really have time to do right now. So yeah, Ubuntu 20.04 Focal Fossa. There's a VM appliance in the Goose D drive and also under the software folder in the Google Drive for the Neil Share drive. There's also I put a bunch of installation images for various Linux stuff in there too. So if you need anything, it's in there. Machine learning project, it works pretty well, like Sam said, but it takes a lot of debugging and stuff. One of the annoying parts that is kind of nice about like coding everything from scratch is that you can kind of see where things mess up more, where as in this, it's kind of like not as easy to find issues. It also seems kind of like the thing where like there's only like one guy, Esri, who actually knows how it works and no one else does. But yeah, I'm tackling most of the actual like paper writing.
Which guy is that, by the way?
Who
It's
knows?
whoever's on the forums saying search it.
Yeah. Yes, I'm writing the paper right now, and that'll be done a couple days. Due Monday. So, as requested, here are some pictures of my hydroponic garden. I just have these 2 bins. I'm growing lettuce, spinach, broccoli, and beets. So it's pretty simple. The tubs are filled with water, and then you have these little net cups that the plants actually sit in, and they send their roots down into the water. And they've been growing. They really like the warm, sunny weather we had last weekend. So.
Did you see the wind chill for tomorrow? It's supposed to be like in the 10s and 20s for us.
Yeah, I'm a little worried about it. Well, I mean, they're all like cold hardy plants, so
Oh, okay.
I'm hoping they'll be okay.
I guess there was a freeze last night. I got woken up by an alert from National Weather Service. So
yeah. Well, we'll see what happens. If they die, they die. I don't think they will. One of the, I don't think they will because the water is kind of a big thermal mass, and I don't think that's gonna freeze. And I can just like move them closer to my house, and that'll be like a slightly warmer microclimate.
you should
Anyways,
space heater it. Put a little space heater next to it.
I thought about putting a fish tank heater in them.
It would keep them warm.
Yeah, but I'm going for the cheap and simple. So the method I'm using is called the Kratky method, which doesn't like there's a lot of more complex methods that like use pumps and stuff, but this is basically plant them and they send their roots down. So I'm about at this stage where the roots are just hitting the water, and then they suck up the water. And you have some roots that are in this nice humid air, so plants don't like drown, but they still suck up the water, which has nutrients in it. So it's supposed to go really fast, and hopefully we'll get that. Another thing I've been playing with is Darktable. It's an open source image editing software, basically like Adobe's Lightroom, but free. So it's good for developing raw image files. It's not too difficult to use, and there's a lot of documentation out there online. Another thing that's cool about it compared to like GIMP or Photoshop is that it's non-destructive, so it doesn't actually edit the raster. It just keeps the original and saves the edits you apply to it, and then you can like export the edited version of it. So you can always go back to whatever steps and you won't lose anything. So this is what it looks like. You have your like history tab, so if you click on any of these, you go back to like that step they did. And has tons of tools, like a lot of open source stuff. There's kind of a lot of ways you can do the same thing. This is just a quick edit on this photo. Of the left is like raw, unprocessed, and the right is just with some like 2 minutes of editing.
Awesome.
Yeah. So if you ever need to develop raw files, that's a nice tool. So goals for next week, I want to finish and submit machine learning on Monday. That's kind of top priority right now. Then take some time and relax. Cross my fingers because they are still stuck around the spring break for grading. So who knows what grade I'm going to get in that class. Finish proposal and get that out to necessary people. That's kind of like the next top priority. And then keep messing with the Google Cartographer. I want to run the Puerto Morelos beach scan data that Dr. Pingle got when he was down there through HGeoGraphSlam, and then eventually Google Cartographer when I get that up and running. So that's all for me.
All right. Thanks, Jack.
Yeah, they said that they would get the grades in last week or the week before for homework from February, but just away.
Yeah, it's fine.
Yeah,
I
yeah,
don't need to know.
yeah, it's under control. It's under control.
Colleen, I know you don't have a report prepared. You want to talk about some of what you're up to next week once classes settle down?
I kind of have a little bit of a report prepared.
Oh, great.
It's just a short one. So, I didn't get as much done research-wise. I got really depressed, and I'm just now realizing how bad it was. So this week has mostly been catching up on classes and stuff, but one thing that I was able to do sort of related to research was the 5004 stuff, which was like listening to a bunch of different talks. So that was useful. As I mentioned, a lot of this week was catching up. I got my plan of study back from Dr. Carstensen. And while I haven't been able to get much done these past couple of weeks, the good news is that I have plenty of time to work on it over the summer because my internship was canceled. But as it says, I'm not where I wanted to be, but I can work with this. Words of wisdom from Doctor Who. One person I came across while listening to the stuff is Dr. Sarah Parcak. She's a professor of archaeology at University of Alabama, Birmingham, and she actually uses satellite imagery and remote sensing techniques to find archaeological sites. And she even has this open source thing that she came up with some other people where it's kind of like the thing Sam mentioned earlier, where it's like, it gives you tiles and you mark whether this tile has like an archaeological site, yes or no, or like, has this place been looted by people, yes or no? And so that was interesting to learn about.
Yeah, ooh, if you find out more about that, I'd love to hear more about it at one of the lab meetings. That sounds awesome.
Yeah, I agree.
In one of these TED Talks, there's like a link to it where they mention it, and I looked it up and it seems pretty interesting. Definitely something I'd be interested in working for when I get out of grad school, but we'll see. I was able to listen to some of the symposium. It focuses on the Inca roads, but this one was about like the infrastructure, because I thought it would be useful to like have an understanding of how the empire worked in order to get an idea of like what might be useful for me for the least cost path analysis.
Yeah.
And it's a lot more we usually think of things in terms of Western society, but the guy mentioned that their economic structure is not so much what we have as an economic structure. Like there was no monetary system, and taxes were like paid in the form of labor. So like it's very different from how societies are generally run today. So that was interesting to learn about. This was a symposium where he mentioned that one of the things the Inca did do was when they would go to a place, they would take some people from, when they would conquer an area, they would take some people from that village and put them in a different village, kind of as a way to keep uprisings from happening. So I don't know if that means that they brought some of the stuff with them from their old village, but that would be interesting to look into. And then there was this one, which was Eric Sanderson came up with a way to like model the ecology of Manhattan Island, which is where Manhattan is today. And like he was able to figure out probable areas of where some Native Americans were settling in that area. due to a bunch of different factors. So I was thinking of looking up a paper on that to read over the summer, because it might be useful later on. Just to like, if you can recreate the ecology, it might be able to help find paths of like, this is most likely where people traveled and such. So that's something I wanted to look into. Goals, work on my proposal, finish classwork. I got an extension to work on the algorithms class because I did get pretty behind in a couple classes. As I said, I didn't realize how depressed I was until very recently, but thankfully I'm on antidepressants now and that's helping, and just try to keep chugging away at things.
All right, sounds great. I didn't know that you were a Doctor Who fan.
I am. We were in this weird like timeshare place where they had a satellite TV, but they didn't have, they had a VCR player, but not a DVD player. And this was like 2011, 2012-ish. So like when I was just beginning high school, and there was no Wi-Fi, like no cell service. And like we had this VCR player, but we had satellite TV, and there was a Doctor Who marathon on because it was Christmas break. So we watched that and kind of got hooked on it.
Cool. Yeah, I watched the first couple of seasons and then I sort of fell off the wagon, but everybody seems to like it, so I might try to get that back in there.
Yeah, the first episode I saw was Angels of Manhattan, which is not a good one to start on.
Why?
Well, my favorite companions were Rory and Amy, but that's the one where they stop being the Doctor's companions. So it's not the best of places to start because it's an emotional roller coaster.
All right.
That
Well, thanks everybody for making the time. It was good to see some faces again today. We'll see everybody back again on May 22nd. And we'll probably see people at Hudson's Defense on Monday, right?
Definitely.
Very good. All right.
Yeah.
With finals,
that Manhattan project thing that Colleen was mentioning.
What's that, Hudson?
I saw recently, like, I think it's the ride up the One World Trade Center. They have like a simulation of Manhattan from like colonialization all the way up to like 2015 past like the World Trade thing. It's really cool, like simulation going through all the years, like kind of thing.
Interesting.
But, yeah, I saw that recently on like some social media. Thought it was cool.
All right. Cool. Thanks for sharing.
All right. All right. Well, take it easy, everybody. Jim, good luck with everything.
Thanks, I'll try.
See you, everybody. Bye.
See ya.